And did I hear you say all 4 of them? So Abel says there's 4 of them. So I am going to draw what the models are. So the denominator's 3 because it's sliced up into 3 parts. 1 is highlighted. And he said there were 4 of them. Okay. All right. Do I ever change the denominator when I'm adding? Never. So that stays the same. I add the numerator and I get 4/3. That one, the way it is improper. So let's switch it to a mixed number. Can you see that it's higher than 3 in the numerator? So that's the same thing as saying 3/3 plus 1/3, right? And 3/3 is equivalent to 1 plus 1/3. So my answer would be 1/1/3. Let's look at the next one down below. You can use multiplication with fractions to show repeated addition of fractions, just as you do with whole numbers. Complete the sentence and equation below. How many models do you see, Abby? 4. I'm going to put 4 here. And they all have a denominator, so they're cut into 3 pieces, and one is, sorry, why do we not have our pencil in our hand? They all have 1 shaded. And I am going to add, the denominator is a 3. And I'm going to add the numerators right here, which is the same thing as plussing them, 4/3. So 4/3 goes here. I'm going to simplify this. What is 4 always sitting on top of? That's always sitting there when you have a whole number. Levi? What is 4 always sitting on top of? There's a number it's always sitting on top of. 1. A whole number is always sitting on top of a 1. Always. So now when I look at it, did you see that the symbols changed? It's multiplication. There's new rules. So when you add or subtract, the denominator never changes. When I am multiplying, I times the top. 4 times 1 is 4. I times the bottom. 3 times 1 is 3. Did I get the right answer? The same answer? Yes. Turn the page. Let's look at the model again. I'm going to put little plus signs right here. The models change. Now I can see that 2 of each model is colored in. So it looks like 2/3 plus 2/3 plus 2/3 plus 2/3. When I'm adding, the denominator never changes. 2, 4, 6, 8, 8/3. And just because we're trying to get really good at mixed numbers, let's fix this one. 3 goes into 8 2 times. 3 times 2 is 6. I get a little tiny 2. So 2 whole, still a tiny number, and I look around to find the denominators. All right, on A, write an addition equation to add 2/3 S. That's exactly what we did right here. Okay, so we're not going to rewrite that. It's just sitting right there. Complete the multiplication equation. All of these models are the same. Okay, and there's 4 of them. So I know that they represent 2/3. 4 sitting on top of what imaginary number, Levi? 1. When I'm multiplying, new rules, I can times across. 4 times 2 is 8. 3 times 1 is 3. 8/3 got me to the same answer. Let's keep looking at this. Look at the model below. It has, I'm going to write it down here now, 1, 1, and it's cut into 3 parts. 3 parts. Okay, so there's that guy. Just drawing the equation out instead of model, just as a fraction. Okay, plus signs. When I am adding, the denominator never changes. So that stays 3 all the way across. Now I add the numerators, all of them. 1, 2, 3, 4, 5, 6, 7, 8. 8/3. All of the models look the same, and there were 8 of them, so I'm going to put 8 here. 8 sitting on top of what pretend number, Levi? 1. If I'm multiplying, I take 8 times 1 and get an 8. 1 times 3 and get a 3. I got to the same answer. Turn the page. Let's try it again. This is pretty easy, right? Complete the statement and equation below for the fraction model. It's in how many parts, Caleb?
1/4.
Yep, they're all 1/4. Okay? The denominator stays the same. They all match. How many are there, Luana? 5. I put a 5 here. Levi, over top of what number? Okay, but we're not going to put it there. We're going to wait till we get to the bottom right here. 5 over 1. 5 times 1 is 5. 4 times 1 is 4. Okay. Five copies of, we got to do this one here. We want to make sure we got all the stuff figured out. Okay. Looking great. Turn the page. Number 3. Look at the model below. What's that model representing? Sawyer? Ava, go to the round table. 3 what? 3/4. So this is 3/4 plus 3/4. Oh, I'm just going to do it right here where it wants me to do it. Okay. So we have 3 of them. They represent 3/4. Does the denominator change when I'm adding, Marcus? No. 3 plus 3 plus 3 is 9. 9/4. Complete the multiplication equation. 3 models look the same times 3/4. It's sitting on top of an imaginary number. 1. 3 times 3 is 9. 4 times 1 is 4. Let's go to 4. Man, the screen does not think my fingers work today. Look at the model below. What's being represented in this one, Dryston? 1/4, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to draw it 9 times. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. I got to do one more. Does the denominator change when I'm adding? No. Then I add up all the random pieces in the numerator. That's 9 9/4. Or, because I don't want to waste time drawing models and drawing out those simple fractions, I'm going to multiply 9 times 1/4. Sitting on top of a 1, 9 times 1 is 9. 4 times 1 is 4. Okay? All right, now it's making it real easy for you because it's keeping the denominator of the whole number a 1. So 1 times whatever is always that number, but it's going to get harder.